Ever had one failing service bring your whole application down? That's a system outage waiting to happen. Let's fix it with the circuit breaker pattern. In a microservices architecture, services rely heavily on each other. But what happens if one of those services becomes slow or fails completely? The circuit breaker pattern prevents repeated attempts to call a failing service. It detects failures and trips the connection, just like an electrical fuse. It works through three main states. Closed, all calls go through. Open, calls are blocked due to high failure rate. Half open, a few calls are allowed to check if the service has recovered. Let's explore how the circuit breaker pattern is implemented using Resilience4j in a Spring Boot microservice. We start by annotating our service methods with @circuitbreaker. This enables automatic fault tolerance handling based on the configuration we provide. Here we have two sample endpoints, one simulating a healthy service and another designed to fail. The fallback method ensures graceful degradation when failures are detected. Circuit breaker parameters such as failure thresholds, wait duration, and half-open behavior are defined in the application properties file. Now let's start the server and test the application. Calling the healthy service returns a successful response as expected. Now we're making repeated calls to the unhealthy service. As failures accumulate, the circuit transitions from closed to open. At this point, the circuit is open. Further calls to the unhealthy service no longer hit the service itself. Instead, the fallback method is triggered instantly, reducing load and improving resilience. By using Resilience4j, we've added robust fault tolerance to our microservices, ensuring service failures don't cascade across the system. This concludes our demonstration of the circuit breaker pattern using Resilience4j. For the complete implementation and source code, please refer to the GitHub repository linked in the description. Stay tuned for the next video where we'll test your understanding with a short quiz on the circuit breaker design pattern.